Just a second.
Okay, hello guys, welcome back. And we'll start with Java 8 part 2. So the last 10 questions on part 1 has already been covered in the previous video. I hope you will like it, this part, and let's start. So the question here is, why do we need a functional interface in Java? So before this, I'll tell you, a functional interface was always been there before Java 8, but they are not used that for that particular reason, which we are using it now, that are called in, they're used in Lambda expressions. Just give me a moment. Okay. So in functional programming, what you can do, you can treat the code as the data. For this purpose, the Lambda expression has been introduced. So they can be used to pass a block of code to another method or an object. And this interface, it serves as a data type for Lambda expressions. So since a functional interface contains only one abstract method, the implementation of that method becomes the code that get passed as the argument to another method or object. Okay. Now, is it mandatory to use the functional interface annotation to define that in Java? No, that's what I told you in the last video. Go and check that out. It is not mandatory to mark a functional interface with functional interface annotation because Java doesn't impose this rule. Okay, so if you mark it as a functional interface annotation, the Java compiler will give us an error in case we are defining more than one or two abstract class. One abstract class. Sorry, two, it will give an error for sure. Now, what are the differences between collections and stream API? So this is a good question. It will come to you if you are giving any questions on congruent and all those things, right? So do check out all these questions are there in my video. I'm sorry I'm taking some time, but I'll do it unless until you get to know that there are videos of like that. So version. So collections API is actually introduced in Java 1.2. However, streams are coming in Java 8. And what are the usage? So collections API is basically for storing data in different kind of data structures. Okay, like stack, list, hash map, queue, linked list, and all those things, right? Stream API is used to compute on the data on a large set of objects. Understand this. You can store in via collection API. Via stream API, you can compute the data. Okay. Then finite. So with collection API, we can store a finite number of elements in data structure. Okay. With stream API, we can handle the data which contains infinite number because we can always put into a array of streams and we can take one stream at a time. Then there is always a concept of eager and lazy everywhere. Okay, so eager means immediately and lazy means whenever it's time will do. So collection API will construct the object whenever it gets the data structure immediately. Stream API will take a time, will take it through step by step, like our dad used to say, take one step at a time. That's what stream API will do. Now, multiple consumption. Most of the collection, they support iteration or consumption of elements multiple times, right? While Stream API, we can consume or iterate element only once. So this is a good part. Now we have talked about differences. Now we'll talk about uses. So we all know because a Stream API kind of gives a flexibility to helps using the data in a declarative way. If you don't know declarative way, it can or an imperative way. It's basically declarative means a human can also understand this. Suppose there is a SQL, right? A SQL query or SQL query. You want to fetch how many males are there in the country. So you can get the table from country where males, where gender is equals to male and select count of star. So you know a count of gender persons you can do. So this is a declarative way. You know what you are doing. But for imperative way, it's basically you are going into checking for int I is equals to for countries, you can say, and then for int man is equal to for I is equal to 0 in countries where country is equals to India, suppose, and gender is equals to men, count plus plus. So it's like this, and that's why you're doing it in an object, right? So and the stream API will do it with the help of filter and a method. So that will be a good thing. Now, with the Stream API, we can also make a good use of multi-core architectures. That means without worrying about the multi-threading code, because we know nowadays CPUs are coming with dual core, octa core, quad core, like that. So, and we can create a pipeline of data operations with Java Stream that can run in sequential or parallel. Okay. It provides support for group by, order by, like I talked about, declarative way, and it also supports the writing the code in a functional programming style, and it provides parallel processing of data. So all good points, right? Now, what are the difference between intermediate and terminal operation? See, we all know what an intermediate is. It's a person who stands in the middle, right? So, and terminal operation is the one who will end it all, right? Now let's talk about the differences. So first, what evaluation. So intermediate operation will not be evaluated until we chain it to a terminal operation of stream. And terminal operation can be independently evaluated. That means if we do a filter, and then what to do after that? We have to do system dot out the printer and right, or maybe count. That is the terminal operation. Now output. The output of intermediate operation can be another stream altogether. But the output of terminal operation is not a stream. Then lazy. Intermediate operations are evaluated in lazy manner. Let it come. I'll do it. Terminal operations are evaluated in an eager manner. Okay. Chaining. We can chain multiple intermediate operation. Terminal operations cannot be changed. And there are multiple intermediate operation in a stream operation. There can be only one terminal operation. Okay. Now, what is a split split iterator in Java? It's a special type of iterator which can traverse and partition the elements of source. Source can be collection, an input-output channel, or a generator function. The split iterator or a split iterator may traverse elements individually or sequentially in bulk. Okay, this is a good point. Now, the main thing which you are here, the iterator versus split iterator, what is the difference, right? So, split iterator can be used with streams. Iterator can only be used as collections. That's good thing. Split iterator uses internal iteration to iterate streams. However, iterator uses external iteration to iterate collections. Okay, we'll talk about it in more detail, but this is how you can talk in the interview. So iterator can iterate streams in parallel as well as sequential. Iterator will only do it in sequential, right? That's the advantage of streams right now. And iterator can traverse elements individually as well as in bulk. Iterator only iterates element individually. So to summarize this point, we'll just talk it out. Differences, it comes with Java 8 and works with streams. Iterator works with collection. It split uses internal iteration, and iterator uses external iteration. Split can work with parallel and sequential. Iterator can only work with sequential. And split can traverse elements individually as well as in bulk. Iterator is the only one who will do it in individually. Okay. Now, what is a type interference in Java 8? So it's basically a Java compiler can see each method's invocation and it declaration to determine what type of arguments are required, right? So by type in inference, what we are doing is, I think I said in interference, it's inference. Java can determine the type of arguments as well as the type of result being returned. Okay, so that's a good thing. Also, type inference algorithm also tries to find the most specific type that can work with all the type of arguments. So that's good. Now, does Java 7 support in type inference? Yeah, it does support, but there has a more enhanced concept which is coming into picture. We'll use that into defining Lambda expression, method references, and functions. Okay, that's good. Now the last question for this video. I know 10 questions are less, but I think that's how you will learn. How does internal iteration work in Java 8? Quickly refresh what internal iteration, where have you seen this in this video? I'll take a pause for 1 second. You can pause it and think. Now the answer is split iterator, right? It uses internal iteration to iterate on streams. So in an iterator, the fundamental question is that which party controls the iteration? Is it the iterator or the collections on which the iterator runs? So when a collection controls the iterator, that is called external iterations. We have used it, which iterator uses external iteration is the iterator, right? So when the iterator itself controls the iteration, it is called internal iteration. So in case of internal iteration, the client hands over an operation to iterator, and the iterator applies the operation in all the elements. Okay. Internal iteration is easier to implement because it's like own house, since the iterator does not have to store any state of the collections. So guys, I hope you like this, and we'll move on to next video. I hope it should come like in this today itself, but I hope this you like this, and I will continue this. I don't know why I stopped, but I think we'll continue this. Okay, so have a nice day. Bye bye. We'll see you another time.